we want to use integration by parts to find the integral of x times cosine inverse of x. Once again, the formula for integration by parts is the integral of u times dv is equal to u times v minus integral of v times du. Here we have x times cosine inverse dx, and so we have to decide something for u and then the rest of it for dv. And once again, this is a trial and error process, and so we let u be cosine inverse of x. If it doesn't work out, then we go back and let u be something else. And so we'll let u be cosine inverse of x. So we let u be cosine inverse of x. Then what's left is x dx. And so we call that dv. And so here we choose to let u be cosine inverse of x and dv be x dx. And record that the derivative of cosine inverse is negative 1 dividing by the square root of 1 minus x squared. And so du is negative 1 dividing by the square root of 1 minus x squared dx. dv is the same as 1 dv. The antiderivative of 1 is just 1 times v. On the right hand side, this is x to the first, so the antiderivative will be x to the second divided by 2. And so we get the integral of x cosine inverse of x will be u times v. This is u, this is v. So it's cosine inverse of x times x squared divided by 2. Minus the integral of v times du. So this is v and this is du. Negative, so here we have minus negative 1, that will become plus, and here we have 1 half, and then here we have x squared dividing by the square root of 1 minus x squared. And to find this integral right here, we have to use what's called trigonometric substitution. So here we let a squared be 1, and then let x be a sine of theta. And so 8 is 1, so we get 1 times sine of theta, which is sine of theta. Dx over d theta is cosine of theta. The derivative sine of theta is cosine of theta. And now we'll make the substitution. X is sine of theta. X squared will be sine theta squared. And then here we have 1 minus x squared, which is 1 minus sine squared. But recall that 1 minus sine squared is cosine squared. One minus sine squared is cosine squared. Cosine and then dx is cosine theta d theta. So this becomes cosine right here. The square root of cosine squared is just cosine. Cosine theta divided by cosine of theta is 1. So what's left is just the integral of sine squared. From trigonometry identities, sine squared is 1/2 minus 1/2 cosine of 2 theta antiderivative of 1/2 just 1/2 theta antiderivative of cosine of 2 theta is 1/2 sine of 2 theta. Here we have the minus 1/2, and then antiderivative of cosine of 2 theta is 1/2 sine of 2 theta. So we get 1/2 theta, a half minus a half is 1/4 sine 2 theta. Again, from trigonometry identities, sine of 2 theta is 2 sine theta cosine theta. One-fourth times 2 is 1/2. And so now we need to rewrite this in terms of x. Sine of theta is equal to x, which is the same as x over 1. Sine of theta is equal to x, which means theta is equal to sine inverse of x. But here we also need to find cosine of theta. So in the place of sine of theta, we can put x, but we also need to find cosine of theta. Sine of theta is opposite over hypotenuse. And so this is the angle theta. Opposite is x. Hypotenuse is 1. This is the adjacent side. So we have x squared plus a squared is equal to 1 squared. And then solve for x. And then solve for a. A will be the square root of 1 minus x squared. So the adjacent side is the square root of 1 minus x squared. The cosine of this angle, cosine is adjacent over hypotenuse, so it will be the square root of 1 minus x squared divided by 1, which is the square root of 1 minus x squared. And so the integral of sine squared will be 1/2 theta, but theta is sine inverse of x, minus 1/2 sine of theta, which is x, cosine of theta, which is the square root of 1 minus x squared. And so in summary, the integral of x times cosine inverse of x would be cosine inverse of x times x squared over 2 plus 1/2, and then times all of this. And this is the answer.